This is Chapter 3, Lesson 6, page 158, Equations and Problem Solving. This is Part 1. If we look at page 158, we're going to talk about defining one variable in terms of another. So today's lesson and what you've been doing in science is going to sound kind of similar. But first, let's talk about the example number 1. We're going to do the quick check together. So it's the problem on the bottom of page 158. The width of a rectangle is 2 centimeters less than its length. 2 centimeters less than its length is important information. The perimeter of the rectangle is 16 centimeters. Some of you are saying this looks familiar because it was on our in-class worksheet. So hopefully you've got an idea of what we're going to be doing. What is the length of the rectangle? This lesson is about defining variables. We've already talked about that. We need to say what is going to be our length and what is going to be our width. We know that the width is 2 centimeters less than its length. So, do we know the length? No, so let's call it L. So in terms of L, can I say the width? It's 2 centimeters less. How do I show 2 centimeters less than? Minus 2. So now I'm looking for perimeter. Perimeter is the distance around an object, so I'm going to add, if I drew a rectangle, and I know that my length was L, and my length was L, and my width was L minus 2, and my width was L minus 2. Could you find the perimeter? What would my equation look like? What do you think, Cole? It's going to be L plus L plus L minus 2 plus L minus 2. And that's going to equal the perimeter, which was 16. Let's look for like terms. Here's an L, there's an L, everywhere's an L, L. How many L's do I have? 4. So 4L. Done with that, done with that, done with that, done with that. Minus 2, minus 2. Minus 4 equals 16. Okay? You could be saying to yourself, all of these are factors of 4. I could solve a strategy or use a strategy there, or I could go back to just solving a two-step equation. I think Stormy would rather just solve a two-step equation. So plus 4 plus 4. So 4L equals 20. Well, if 4L equals 20, then if I divide by 4, I will find out that L equals 5. Am I done? Jessica, you're right. I'm not totally done because I was asked what is the length of the rectangle. L is 5, so the length of the rectangle is, length was just L, so it is 5 centimeters. That is my answer. Moving on to consecutive integers. Consecutive integers is at the top of page 159. It says consecutive integers differ by 1. And that is true when we're talking just strictly about consecutive integers. Because if you think about it, consecutive means in a row or in cardinal order. So if I had the number 17, the next integer would be 18 and then 19. Those would be consecutive integers because from 17 to 18 is 1, and from 18 to 19 is 1. But from 17 to 19 is 1 plus 1, which would be 2. Sometimes we may talk about consecutive even or odd integers. Notice then that if I went odd and I had 17, the next odd integer would be 19, and then it would be 21. And from 7 to 19 is 2, and from 19 to 21 is 2, but from 17 to 21 is 4. Just keep that in mind as we begin to work on problems about consecutive integers. If you notice on page 159, example 2, they talk about defining the variables. Here's our question. The sum, keyword, of 3 consecutive integers is 48. Find the 3 integers. I need to define variables. So I need something for number 1. I need something for number 2, my second consecutive number. And I need something for number 3. Okay? Number 1, do we have any idea what the number is? You're right, Jack, we don't. So we're going to call it n for number. We know that number 2 is consecutive, which means if I have n, the next number is n plus 1. And the third number, well, it's going to be 1 more than the second number, so it's n plus 1 plus 1. Can I simplify that? N plus 2. So if I'm looking for the sum again, what does that mean I'm going to do with all 3 of these numbers? Add them together. So I have n plus n plus 1 plus n plus 2 equals 48. Do I have like terms? Here an n, there an n, everywhere an n, n. I have 3 of them. 3n. Done, done, done. Plus 1 plus 2. 3n plus 3 equals 48. Back to a simple 2-step equation. Subtract 3 from both sides. You got it, Cassidy. 3n equals 45. Divide by 3. Isaiah is becoming an expert. N equals 15. Are we done? We're supposed to find the 3 integers. Well, if n is 15, what number was just n? Number 1. So my first number is 15. That means if they're consecutive, my next number would be 16. My last number would be 17. If I take 15 plus 16, what do I get? 33. Is 33? No, it's not 33. It's 31. Is 31 plus 17 going to give me 48? Yes. So I know these 3 are my consecutive numbers, 15, 16, and 17. Let's do one more. Let's talk about consecutive even numbers. I need to define my variable for number 1, number 2, and number 3. See what you come up with and see if it matches what I put in about 5 seconds. My first number I'm always going to say is n. These are even numbers. So my second number, is it going to be n plus 1? If I'm doing even numbers, that's like 2, 4, 6. From my first number to my second number is how much? 2. So it's n plus 2. So for my third number, from 4 to 6, it's 2 more. N plus 2 plus 2, or n plus 4. Their sum, word means I'm going to add them together. So n plus 2 plus n plus 4 equals 78. Combine your like terms. 3n, yes, Joelle, plus 6 equals 78. Maybe you want to factor out some numbers, but I think that Chris would want to just solve it like a two-step equation by subtracting 6 from both sides. 3n equals 72. Divide by 3. Divide by 3. N equals 24. And therefore, our three consecutive even integers would be 24, 26, and 28. The sum of those numbers should be 78. That is the end of part 1. I'm going to now begin part 2.